Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, I'm back with another lecture. As far as class 9th is concerned, we are continuing the topic actually, that is atom. That's from the unit Atoms and Molecules. Last time we finished Dalton's atomic theory. After Dalton's atomic theory, we discussed what actually this atom is, and I told you people that this atom is actually ultimate particle of matter. That was actually the basic nitty-gritty of the Dalton's atomic theory. I told you people that Dalton's atomic theory revolves around this atom. It's actually the concept of atom as the smallest particle of the matter. Without thinking about this atom, it's that impossible for we people to study matter. So, today we are going to study something more about this atom. Why I am giving you back to back lectures on this atom to make you people understand what actually this atom is, and I am making you people understand from the molecular level. How now the question arises, how big are atoms? Last time I told you people that these atoms are very small, very minute particles. In fact, they are smaller than anything we can imagine or compare with. Around more than millions of atoms, when joined or stacked with one another, and they form I can say the layer of atom, just like a sheet of a paper, my dear students. And the size of atom, I told you people in the last video lecture that the size of an atom is expressed as atomic radius. Atomic radius, my dear students. And I told you people that it is generally measured in nanometers, my dear students. And I told you people that the nanometers are related to meters as, for example, I told you people 1 nanometer is equal to 10 raised power minus 9 meter. And 1 meter is equal to 10 raised power 9 nanometer. And so actually the relationship between the nanometers and the meters. I mean, say nanometers are related to meters as. And I give you the concept of this, how the atoms are, how I can say big these atoms are. So let's discuss something more regarding this atom. Let me tell you one thing. Hydrogen atom, for example, atom of hydrogen is having atomic radius of 10 raised power minus 10. Mark my words, my dear students. This is a very important concept and jot it down with me. And these things have been asked so many times in the examinations. Atom of hydrogen. The radius of atom of hydrogen is 10 raised power minus 10 meter. 10 raised power minus 10 meter, my dear students. I can say we are calculating actually this atomic radius related to meters, my dear students. So, second is molecule of water. Molecule of water is having atomic radius of 10 raised power minus 9 meter. Mark my words, students. Atom of hydrogen is having the atomic radius of 10 raised power minus 10. Mark my words, approximately we are calculating, my dear students, we are calculating the atomic radius in meters, my dear students. So this and the molecule of hemoglobin. Molecule of hemoglobin is having atomic radius of 10 raised power minus 8 meter, my dear students. It's a molecule of hemoglobin. Molecule of Molecule of hemoglobin, 10 raised power minus 8 meter, my dear students. So radius of molecule of hemoglobin. And let me tell you another example. It's a grain of a sand. Grain of a sand. I mean, say the radius of grain of a sand is equal to 10 raised power minus 4. And watermelon, my dear students, atomic radius of molecule of, I mean, say the atom of this watermelon is called 10 raised power minus 1 meter. These were some of the, I can say, atomic radius of the following atoms. Now, for example, the relative size of atoms and molecules as compared to the common species. I just gave you the concept of, I can say, atom of hydrogen is 10 raised power minus 10 in atomic radius as far as atomic radius is concerned. Molecule of water is having atomic radius of 10 raised power minus 9. And the molecule of hemoglobin 10 raised power minus 8. Grain of a sand 10 raised power minus 4. And watermelon 10 raised power minus 1. So this was actually how big are the atoms. We might think that if atoms are so insignificant in size, then why should we care about them? The question arises, for example, somebody will pose your question, that a layman will pose your question that if these atoms are very meager in size, that means they have a meager mass and meager size, then why to bother about? Why to bother about, my dear students? Why should we care about them? But the fact is, my dear students, we can't ignore atoms because our entire world is made up of atoms. We may not be able to see them because they are extremely small, but atoms are there and are constantly affecting us whatever we do. So now the question arises, somebody will pose you a question that if the atoms are very meager in size, the moment I'm telling you they are meager in size, that means insignificant in size, then why to bother about? Why should we care about these atoms? In fact, but the fact is that we can't ignore these atoms. And I told you people that wholly or solely matter is made up of, I can say this, these atoms. And it's dead impossible, my dear student. Jot it down and mark my words. It's dead impossible for we people to get the knowledge regarding the matter without considering, without taking consideration of atoms. So we can't ignore atoms because our entire world is made up of atoms. We may not able to see them because they are extremely small, but atoms are there and they are constantly affecting us whatever we do. So now the question arises, how we can see these atoms? No doubt they are meager in size, but we do have tools because we live in 21st century, we live in the modern age, we live in the age of science. Now how can we, I can say, see these meager particles, I can say indivisible particles, indestructible particles? Now the question arises, how we can, I can say, see these very, very small particles. We do have certain instruments by which we can see these atoms by our naked eyes. For that we had to study a microscope. That microscope is called as scanning tunneling microscope. Let's discuss scanning tunneling microscope, my dear students. So let's discuss regarding this scanning tunneling microscope. STM, my dear students. This is scanning tunneling microscope. Here the question, the thing we are going to discuss is that if these atoms are very meager in size, insignificant size, then how we can see them. Modern technology has made it possible to take photographs of atoms. but that was done with the help of sophisticated, I mean say authentic instrument called as scanning tunneling microscope. Scanning tunneling microscope. It's actually an instrument for imaging surfaces of the at the atomic level. That's why I told you people that we can see the atoms. Look, atomic level. You people will see the surfaces of, I can say, atoms, but at atomic level. It was developed in 1981, and its inventors Gerd Benning and Heinrich Rohrer the Nobel Prize in Physics. They were actually the two physicists, Gerd Benning and Heinrich Rohrer. The Nobel Prize, they actually got the Nobel Prize in Physics in 1986, my dear students. For an STM, good resolution is considered to be zero point 0.1 nanometer. Look, my dear students, lateral resolution and 0.01 nanometer depth resolution. That means, and I can say this, as far as this scanning tunneling microscope is concerned, we can take the photographs of atoms, and we will come to know that this scanning tunneling microscope will actually show us surface of atoms by taking the photographs of particular, I can say, particular thing as far as atom is concerned. So as far as this scanning tunneling microscope is concerned, it's an instrument for imaging surfaces at atomic level. That means by making use of scanning tunneling microscope, we may able to see the surfaces of atoms by taking the photographs of the particular, I can say, atomic surface. So a scanning tunneling microscope is an instrument for imaging surfaces at the atomic level. It was developed in 1981, and as it was developed in 1891 by Gerd Benning and Heinrich Rohrer, and they got Nobel Prize in 1986 for the same invention, my dear students. That is for scanning tunneling microscope, and it can have resolution of 0.1 nanometer to 0.01 nanometer. So it can show us the surface of the, I can say, atoms, but mark my words, at atomic level. So by making use of this scanning tunneling microscope, we can see the smaller atoms by taking the photographs of the surfaces of the atoms. So somebody will pose your question, how we can see the atoms. You people should answer in a jiffy that we do have a sophisticated instrument. That instrument is named as scanning tunneling microscope, STM. This is actually these are actually some of the photographs taken by making use of STM, a scanning tunneling microscope. Look, by taking the photographs, we can see the, I can see layers of the atoms. So this was the scanning tunneling microscope. So it was invented, it was discovered in 1981, and the two scientists, Benning and Heinrich Rohrer, they were actually the physicists. They got the Nobel Prize in 1986 for the same, for the scanning invention of scanning tunneling microscope. This was something more regarding this atom. In next video lecture, we will study some more things regarding this atom. Till then, stay safe, stay blessed, and stay at your homes. Allah bless you all.